Hello and welcome to the British Cartographic Society's GeoViz Toolkit Webinar series. I'm Chris Rabutis, BCS Vice President and today's Chair. Today's session will explore what good geospatial dashboards look like in practice with our speakers, Ed Parsons and Professor Richard Kingston. Ed Parsons is a leading digital geographer and geospatial technology advisor, known for shaping global geospatial strategy at Google and across the wider industry. Professor Richard Kingston works at Manchester University on a NERC-funded project and is a leading expert in urban planning and geographical information science, driving national digital information through NERC's Digital Solutions program and advancing participatory spatial decision-making. The format for today will be 30 minutes of presentations, followed by 50 minutes of Q&A. So, without much further ado, I'll pass over to Richard to kick us off.
Right, well, thank you for that introduction. I think the last time I did an event for the British Cartographic Society was at one of their annual conferences quite some time ago, because I did a talk all about geospatial data on the internet. And I always remember someone in the audience telling me that this was not cartography, which was making me smile, sort of thinking, maybe 15, 20 years now on from that, the lack of paper maps versus digital maps. And I'm sure Ed can say a lot about that as well in terms of Google and things. But it's kind of interesting just to reflect back on that, about a time when I felt quite intimidated by someone in the audience who was a lot older than me, telling me that I was not doing anything to do with cartography and I needed to get back to paper maps. But here we are today in a world where everything is very digital. So what I am doing at the moment, I've kind of been doing, let's say, doing GIS for like over 25 years now, and so I first started putting GIS on the internet many, many years ago when I worked at the University of Leeds. And for me, it's always been about how do you democratize access to geospatial data. And fast forward 20 odd years, and I was given the opportunity to lead this big program by NERC, the Natural Environment Research Council. And NERC hold over 40 petabytes of environmental data. And our job is to make that data what we call fairer, following the FAIR principles, making it findable, accessible, interoperable and reusable. And a particular remit for what we're doing was to make that all of this petabytes worth of data accessible to non-academics across the UK. And we say it's only if you connect that data with the environmental data that NERC hold in one of these 5 data centres with other social, economic, health and other environmental data that you get real value out of that, particularly if you're in government or even the private sector and third sector, where there's potential value in a lot of this data. So the real challenge there with how do we meet those FAIR principles when there's so much data? And just building something like data.gov.uk, maybe it wasn't, we thought, the way forward, and we need to develop a series of use cases that illustrate the kind of art of the possible for this data. We do have a big challenge at the moment, though. The project runs until the end of this September, and we're thinking now about how do we keep that sustained in the future. But one of the real challenges, though, that we had, as I said, was about how do you make sure you build something that is fit for purpose. And our overall approach was basically not to say, build it and they will come, a famous line from that film Field of Dreams. If we'd have built this system and then today I'm sat here telling you, we built this great thing, the Digital Solutions Hub, it can do A, B and C. I'll get questions at the end saying, well, that's great, but what about X, Y and Z? We want it to do these other things. So we spent the first 2 years out of 5 years going around doing user workshops across the UK to understand what users wanted and the sort of challenges they face with accessing and using data, and particularly geospatial data, particularly when our remit is for non-academic users and often users who have not got a mapping or geospatial background. How do we build a solution that is fit for purpose for a very diverse audience when you're not maybe dealing with people who've got degrees in geography and cartography and GIS and things. And one of the real challenges was how do you actually discover what data is available? And NERC have something called the Data Catalogue Service, but it uses keyword searches. So if you ask a question, our kind of typical question our users would ask is, where will be the hottest place in the UK in 2030, you don't get any results. But what we've been able to do over the last couple of years is start to think about how can we use AI and large language models to actually help search and discover the data that sits in these data centers, but also non-NERC data as well in other data catalogues, things like DEFRA, Environment Agency, Met Office. And we started to think, well, can we make use of a large language model? And what we're doing is using something called RAG, Retrieval Augmented Generation. So there's a lot of skepticism around large language models and concerns around hallucination. So what we did was we designed a system where we take the metadata of that 40 petabytes of data, we take metadata from DEFRA, Met Office and others, put that into a database, and that when you ask the question, where will be the hottest place in the UK, this first version we developed a couple of years ago, then retrieves links to data sets, lists of data sets that are going to help you answer that question. So what that's doing is overcoming that concern that a lot of users have around hallucination with these kind of tools, because when you ask this question, it's retrieving the results from the metadata and the actual geospatial data that sits in one of these data centers, or in this case, UK, climate projections from the Met Office. So we start to overcome some of those problems that some users have around large language models. And here's another step on from that. What we then did, this is using Claude, and we've been experimenting with this, of how can we present data in ways that are open, that people can trust what's going on. And what we've done here is we've fed the database using this retrieval augmented generation method. We've put the metadata into a database. We then ask Claude to connect to that particular database. And what we've done here is asked Claude, can you identify all the places across the UK where elderly vulnerable people to climate change live? And if I just pause it at this point, that's quite good timing. What we've got here is it's picked out some census data, and we've got all pensioner households, but it's also identified single pensioner households. So it's understood, the power of that large language model and understanding of meaning in language has meant that when we've said elderly population, it's kind of thought, oh, well, elderly could mean all sorts of things, but certainly it associates elderly with pensioners. And it knows, because we've asked for vulnerable populations, it knows that a single pensioner household is more vulnerable than a cohabiting, a couple living as pensioners. And eventually, as this keeps running, it's trawling through. So you can actually see it's extracting knowledge from those tables. We've got data schemes, we've got the actual data from the census in there. We've got some climate change data in there. And eventually what it ends up doing is starting to identify middle super output areas, census units that have high percentages of single pension households that are also vulnerable to climate change. Here you can see it's picking out some MSOAs, Eastbourne, places in North Norfolk, the New Forest, Thanet and things. And eventually what it comes up with it towards the end, maybe I'll just speed this up a little bit, is eventually it comes up with a list. Yeah, so it's now identified the top individual MSOAs, the top 5 in the UK that have elderly people in England. Now, obviously, this is just text at the moment. We've been thinking, how do we move this on to the next stage where we actually can start to map this and visualize this, have some kind of dashboard that makes sense to users who are maybe not experts in the use of geospatial data. So we started to think, well, how can we put a large language model and that sort of natural language prompt in front of a map? And our early experiments were just for Greater Manchester. Basically, we were just testing this out and constraining it just in terms of disk space, the amount of data. So we're just looking at this for Greater Manchester initially, but we've now rolled this out and it works at a UK level. But what we're doing here is, so those of you who are familiar, I guess most of you with GIS, we're essentially doing a point in polygon SQL query on Ordnance Survey's unique property reference numbers, UPRNs. We've attached those UPRNs, a whole series of NERC environmental indicators and DEFRA data. So when you ask it, it's saying here, show me all the UPRNs or show me all the properties where PM 2.5 is greater than, in this case, 2.8. What we see there is a kind of interesting pattern here that's raised questions amongst users as to why is it kind of showing these with a sort of square around it? Well, the reason for that is, as many of you might realise, nitrogen dioxide PM 2.5 is raster data. It's on a grid. So when you ask it those kind of questions, it's giving you data clipped here, in this case, to Greater Manchester. but on those sort of 10-kilometre grid squares, because the PM 2.5 and nitrogen dioxide is gridded data. Equally, though, if we were to ask the same question, show me all the UPRNs in, say, flood zone 2, flood zones are obviously irregular polygons, so you get a slightly different pattern. But we see now a lot of value for this, particularly in local government, where they might be saying, well, show me all the UPRNs within 100 metres of the coastline that might be under raised sea level by 2030, 2040, 2050. So we've been looking at how do we design kind of interfaces that for that non-expert audience, they would understand what the map and what the data is actually showing them. So using fairly simple interfaces, removing a lot of those geospatial analysis tools. This uses something called LangChain to convert the natural language into the geospatial commands in the back end. So essentially what it's done there is this as I said, a point-in polygon SQL query on the data without the user needing to understand that. More recently, then, we've been thinking, well, can we take this a little step further and start asking questions? So this is something we've just developed in the last few weeks and using agentic AI and a large language model. And the tools actually built the interface as well. So we started with nothing. This took 4 hours to build, whereas even probably 6 months ago would have taken weeks of developer time to build this. And what this is doing, probably haven't got time to run through it all and can share the slides afterwards. But it's saying here, show me layers that can help assess flood risk in coastal England. And if we click a bit forward, so you didn't need to go and grab any data. It's pulling data from our spatial data catalogue as part of the DSH. You're asking it these questions. You can click and expand these boxes, and we can see here it's pulled out data here from Natural England. That data that's used by DEFRA and overlaid that on a base map just by asking that very simple question. Show me layers that can help assess flood risk. And we've got other examples in here as well, where you can basically ask it any question you want. But again, thinking about how do we then start to present this data geospatially to an audience that are not experts in using GIS software, but might have questions, want to ask other things. We've been thinking about things like, again, going back to UPRNs, show me all the UPRNs in a flood, in a coastal zone. And because we've got all of that NERC data in there that includes climate projections and things, it can start to pull in and overlay different data sets using a relatively simple interface, but also this ability on the left-hand side to expand the commands that are going in the background, because we know from users they want to be able to trust what this is doing, so be able to drill down and see the fact that this data is coming from Natural England and from DEFRA, as opposed to some other organisation that might have come up with erroneous data. So the users want to know that they can trust the data that is in the system. And we're wrapping up all of this together. So this is pretty much my final slide. Wrapping all of this up in a front end where we have this idea where you can search, visualize, or analyze the data. We're building all of this on top of Esri Enterprise, so the geospatial engine. The back end is Esri's Enterprise catalog, but we are building those our own sort of large language model AI search and discovery tools on top of the underlying infrastructure. And the key here is that approach of using what we call RAG. So making sure that you're essentially constraining your search and your natural language search against the metadata. So when it's giving you responses, users know that that's a trusted environment. So a real challenge here, I think, for us in terms of visualization has been how do you present quite complex information in interfaces that are easy to use for non-specialists. And over the coming months, this will all be released fully open. So there is a link on the final slide which would allow you to go and see our user testing solution, so you can have a play around with those. And then the idea is we're just receiving feedback from that at the moment, and then that will become publicly available over the summer for anyone to use. So you can find more information on the link there. As I said, I can share the slides afterwards, so they can be sent around. There's nothing in here we're trying to hide or anything. But I'll stop there and give Ed his chance to speak as well.
Okay, thank you, Richard, for that. And Ed.
Brilliant. Thank you, Christopher. And thank you, Richard. That was really interesting. It's amazing how quickly this technology is developing, that capability emerging literally on a week-by-week basis. It's a real challenge to keep on top of the speed of innovation at the moment. I've decided to take a bigger picture. I'm not going to show you any particular slides. I want to go back to perhaps some of the fundamentals that we need to think about in terms of how do we communicate geospatial information, geographical information to audiences through whatever is the most appropriate technology at that particular point in time. There's a focus here very much on I guess, a big picture strategic view of a environment, of a data set, of a process. But I think it's useful to go back and look just at the development in the last 30, 40 years and how our approach to managing geographical communication has changed. For me, cartography is all about communication. It's about transferring a message and telling a story using the tools that are most appropriate to us. And for most of our history, most of the time that we've been doing cartography, that was fundamentally paper-based. It was about producing a map or a plan using the principles of cartography to demonstrate, to communicate that particular message, be that a topographic map showing you the shape of the landscape and cultural features on that landscape, or the classic example that we all go back to, the tube map of Harry Beck showing you a very abstract view of a transport network, both communicating very specific messages. In this last 30 or 40 years, I think we have to recognize that has been a fundamental change to how we represent information, because the information itself has changed. Clearly now, today, maps by their nature are dynamic. They're generated for use on a screen. And the restrictions that were put in place in terms of traditional cartography are no longer there. Well, that's good because it allows us to actually recognize the fundamental nature of geographical data in that. And this is, I think, the most important point I want to make. Today, geographical data, we recognize that geographical information exists both in space, but also in time. The temporal element now is absolutely crucial. And there's an expectation in users of geographic information that what they will be looking at is not some representation of the real world from 5 years ago, 6 months ago, or ideally weeks or hours ago. They actually want to see real-time data represented in front of them. So there's been this real, I think, distinction now between the traditional static world view and where we have to live today in the worldview of dynamic data. The other change, I think, is in terms of how we use geographical information. Clearly, it's become much more accessible, largely through the emergence of smartphones that we carry around with us in our pockets. We interact with geographical information all the time using, the Maps application that your phone will come with. But that's also changed the nature of how geographical information is collected and visualized. In effect, we've all become cartographers. We've all become geospatial surveyors and data collectors implicitly or explicitly by using our devices. We are gathering and capturing information in real time, and that information is going to cloud services and then reflected back to us through the mapping services that we use, again, in near real time. If you've used the mapping app on your phone and driving with the real-time information about traffic conditions, you'll see that changes every few seconds to reflect the traffic conditions at any particular point. And that is a global capability. And sometimes you can see the impact of that yourself. If you drive up to some congestion, you drive up to a traffic light and watch the map, you'll see the map will change color from perhaps yellow to red, representing there's now congestion. You have updated the map. Your contribution by showing the fact that you're not moving is being updated and then reflected to the rest of the world. So this sense of mapping the world in real time means that we need to, I think, think about cartography in two slightly different ways. There's a transactional approach where we're looking at maps that do a very particular, a very specific task, so giving you directions, or perhaps illustrating a turn-by-turn set of directions that you might use in, say, a transport network. Go to platform 6, get on this train, get off, turn left, go up a level, get a bus, so on and so forth. There, perhaps the map is going to be quite abstract, or may not even be a map at all, rather a series of directions that are communicated to you, perhaps graphically or perhaps verbally, using other forms of communication. And then perhaps more relevant to our discussion this afternoon, alongside these kind of transactional applications, there's the need to provide the big picture. What's happening at a bigger scale, a regional, national, global scale, and how is the world changing, again, in near real time? This is very powerful. This focuses very much on the discussion topic of today. And a very powerful example of this, I think, is something that we've all seen recently on the television news, where we've seen a map representation of the Straits of Hormuz. We've seen tanker traffic flowing, or in this case perhaps not flowing, through that particular area of the sea, and it's been animated to represent the fact that this is dynamic. The fact that there is no ships moving, that's the message that we're trying to communicate. That's, I think, a really powerful use of the technology that we're talking about today. And when it comes to representing a sort of a dashboard of a dynamic situation like this, we have such a richness of tools available to us. We need to go back to that sense of simplicity, of communicating simple messages, really understanding the user need that we have always done as cartographers. The fundamental tools that we use are now radically different. I thought it was really interesting, Richard's point earlier saying, well, that's not cartography. Well, actually, I think pretty much every form of representation of geographic information, be it graphical, textual, haptic, is cartography. We really need to reclaim cartography as communication of geographical information in its broadest sense. And that brings me on to my concluding comments, if you like. I think we are facing a real paradigm shift, and I'm not overusing that term paradigm, a real change in what we do because of the advent of AI and AI's ability to fundamentally understand the environment around us in an automated fashion. I think it's going to fundamentally change both how we capture information, and you've seen an element of that in Richard's presentation, but more than that, it's going to change the way that we interact. It's going to change the user interfaces that we use in the future. And at an even more, perhaps, fundamental level, it may change the way that we represent and collect geographical information. And to talk about that, I'm going to use a prop. These are, I'm putting on, Meta's glasses. They are seemingly relatively normal glasses, but if you look very carefully, you'll see there's a camera lens in the frame, and that camera lens is in effect seeing what I'm seeing and sending back, when I choose to ask a question, information about what I see to a cloud-based AI that can interpret what I see and send me back information based upon what I'm doing. So I can ask, I'm not going to do it now because I'll have a voice in my head and that confuses me. I can ask, what am I looking at? It will go off, it will do a query to the cloud, come back and tell me the building I'm looking at, or tell me what the weather forecast is, or identify where I am in the environment based on a visual positioning system. It's recognizing the environment, not necessarily recognizing the environment from geospatial data, not from absolute XY coordinates, but from relative to my position. And I think this is the big change, that we will move to interfaces that are a much more human scale, based upon what we can see in any particular environment, perhaps much more detailed, perhaps much more based on a an engineering or model-based approach where we're not representing abstract geographical layers, but recognizing buildings as buildings, pavements as pavements, and understanding at a semantic level how they interact with each other. This is known in I guess the emerging technology field as building world models. World models are, if you like, a digital twin, but a digital twin that in its true sense simulates the world around us. And so how we interact with future systems that represent geographical information, I think is going to fundamentally change. It's going to change in its scale down to perhaps things that we can see in our immediate field of vision. That will, in many ways, change the kind of transactional way that we act and use geospatial and geographical systems in the future. However, the big picture bit, the piece about saying, no, what's happening at a regional, at a global scale, we want to see a stand back vision, a strategic sense. In many ways, that still goes back to the map. The map is still a very powerful way of communicating that. And, in many ways, for lots of applications, you can't beat that shared experience of all standing around a printed physical copy of, a map of the Persian Gulf and seeing what's going on in a shared view around that printed piece of material. So there's going to be a lot of change. How we interact perhaps on a day-to-day basis when we transact with these future services powered by AI, I think is going to change an awful lot, and it's going to change very quickly and in directions perhaps that we don't fully understand or appreciate now. But I do think there is still a need, a requirement for that, big shared experience of standing around a physical representation of geographic information where we can all share that common operational picture, the term they love to use in the defense and intelligence community. That, I think, actually will end up being very similar to what we might have used 10 years ago, 50 years ago, 100 years ago, because fundamentally it just works. Okay, those are my comments. Looking forward to your questions. Thank you very much.
Okay, thank you very much. Thank you very much for that. And so I just want to say thank you to both speakers there. So thank you, Ed, and thank you, Richard. And now we're going to open up to the Q&A. So if anyone has any questions, if you can drop them in the chat, we'll work our way through them. It's I've got quite a bit of I have to say thank you very much to both of you. It was quite good having some lot of interesting views there that you've got to discuss. I'm hoping that should spark some good questions from the audience. Okay, we've got something in already, and as expected, seeing AI usually triggers something there. So warning about AI systems. There are suggestions that AI companies are offering their services as a loss leader, and account that costs $20 a month should soon cost $200. You should include that in your financial planning.
Was that me or Ed or both?
I think it was quite general there, but I think it's just.
I mean, we've some of the stuff I showed you. So that final application, actually, it's an open LLM and it runs on my laptop. We always hear about LLMs, large language models. So there are small language models as well. You don't always need a large one, and particularly if in a geospatial context, you don't need to know everything about the world. We're experts in geospatial geography maps, so you don't need to know everything. So there are ways of avoiding, you don't have to just go down the OpenAI, ChatGPT, Microsoft route or, Anthropic. There are other open source LLMs out there, and small language models. And yeah, the one I showed you of the map, where are all the places that are going to be under sea level, coastal flooding, that kind of thing, is a small language model.
Yeah. I think it's also important to remember, AI is more than large language models. We're very fixated on large language models at the minute because of the transformer architecture that kind of was recently developed, and that allowed us to make quite big leaps in terms of deep learning. But that's not the only set of tools in town that are related to AI. And who knows, at some point in the future, we might go back to expert systems, which were part of AI earlier, and they may well come back again and be of interest to people. Around the pricing, well, hey, welcome to business models. It's a classic business model to get you early on, get you keen on using a particular product, and then make it more expensive.
Okay. Thank you, Rob, for highlighting these key points. There's the AI is a much wider field, and unfortunately, it's one of these things that we only get exposed. That everyone's only exposed. Well, only a few areas are exposed to the public, and well, to such an extent, there's a lot in the background. Which okay, so we've got quite questions coming in now. Okay, next question we have: have the Crown Estate been involved as a stakeholder for DASH leasing round 6 for offshore wind has been announced, and it looks like a tool which could use to speed up the process. What could it be some implications?
Yeah, so yes, we have spoken to them. One of our demo applications is what we call the Where to Build app, which was looking at where do you build 1.5 million homes. It could also be where to protect. You could draw a polygon around Stonehenge and run an environmental risk. Equally, you zoom out a little bit and you can go into the North Sea. And obviously, Crown Estate, I think, have been doing a lot of work recently on mapping all of that. They've got quite a sophisticated GIS system doing it. But yes, we've probably got other data in. I think one of the things we've been able to show is that a lot of the NERC data, those kind of organizations are not aware. What was surprising to NERC when we ran workshops, people were saying, who are NERC? NERC assumed everyone knew who they were, as these research councils do. But, a lot of people have never come across them.
Okay.
So, yeah, actually, one of those data centers of NERC is the oceanographic data center. So I have extremely detailed data about oceans and the seabed and things.
Okay, yes, and it's yes, I think we've got a follow-up question here. It's will offshore and marine data also be available through DASH?
So if it's in a NERC data center, yes, it's in there. What you can also do is if you work in an organization that has data that you have internally, you can put that into the system and make choices about whether you want to share that openly or just keep it within your organization. You can overlay your own organization's data or even data that's on your own machine.
Okay, no, thank you for that. Oh, we've got looks like another one for you, Richard.
Well, so there's some massive challenges in universities at the moment around AI, both for, is AI writing your assignment? AI is very good at writing code. So there's some challenges there. I guess you think questions more, though, about AI within GIS master's programs. I guess, most of the master's programs are doing, will have a programming module. I think you'd have to look at the individual MSCs and see. I'm external examiner on the GIS masters at Sheffield. I know they've got a programming module and have been looking at AI in there. I was just saying one coming in there, the Where to Build app. I've put the link in above to the dev tool. So the Where to Build app is actually built on Esri's Experience Builder. It's fully open. You can go and have a play around that. I'm happy to do a follow-up, John, with you. Probably haven't got time now. I don't want to take over the whole thing and go off on a bit of a tangent, but get in touch if you want to have a chat about it.
Okay. Yes. Richard, do you have anything to add in this? Sorry, Richard. Ed, do you have anything to add in these?
Well, not specifically clear about Richard's application and his great access to data sets. I mean, I think there's probably maybe a topic about master's courses and where you pick this stuff up. I think most master's courses are struggling to keep pace with the change in AI and machine learning and so on and so forth. So, I would rather perhaps focus on, which master's course is going to give you that grounding in geospatial data, geospatial processing, a good grounding in statistics, which is fundamentally behind all of the deep learning that we currently use. And then, as almost as a side project, learn what's the current state of the art in AI and machine learning alongside what you're doing as your master's. So the master's will give you the fundamentals. AI is just happening so quickly now. You almost have to do that independently, I think.
Make it. No, good point there.
Okay. Yeah, I think if you write your lecture course in September and you're delivering the AI lecture, in November, it'll be out of date, won't it? I mean, it's a real challenge, I think. I mean, we've got bids in for funding on AI that was submitted 9 months ago, and we've not heard anything yet. I mean, it'll be out of date.
Oh no! A key thing to highlight that is as a very rapidly moving area at the moment. Okay, so here we have another question for both of you. It's you both demonstrated the huge benefit of cartography. One of you on the basis of specifics, and the other more a more general, almost philosophic approach. As professional geographers are always needing, always been, we are always talking about how to influence the markets, our expertise to a wide and expertise, a market expertise to a wider audience. Are we getting any better these days? Should we be worried about the reduction of TOEFL? Cartographer courses in higher education?
Yes, absolutely, we should. I mean, I'm afraid we're probably not getting better at it when we should be. I think maybe other disciplines are doing what we should be doing. And I think, as geographers, as cartographers, we need to reclaim this space and say, we're the best people for communicating this. We understand the ideas. For me, geography has always been about those two lines of both not only just describing the world as we see it, but explaining why the world is the way it is. So I think, it's our job to better use all of the technology that we have at our disposal to communicate these messages. So yeah, I'm disappointed that we don't have cartography programs that you can go and study. I think, largely perhaps this kind of focus on the cartography of paper maps has hindered us. For me, cartography should be about using whatever tool is available to communicate. And maybe it's a call for a new cartography that is going to be, I think, crucial to solving many of the world's problems. We need to communicate to decision makers fundamentally geographical information.
Yeah, I'd agree. I think what I'd call map. The ability we've tried to employ people who essentially compose maps, create map compositions, and we've struggled appointing people who know how to do that. Just because you can put all the data's out there doesn't mean that someone can just create a map. And there's a lot of skills in this area that I see a lot of maps now created by people who don't understand. So they'll have the wrong colours on a Copleth map. They don't understand the difference between natural breaks, quantiles, all those kind of the basics really. So in one way, I said, democratizing access to this data is good, but there are downsides to that. And you see I was standing on the show writing GIS crime, and it wasn't crime mapping; it was doing terrible things with GIS to create rubbish maps. Well, I think he actually said crap maps, but
yeah, I mean, you're right. And the number of Copleth maps you see made on a Mercator projection, it's like, the very basics. How can you be getting that wrong? Well, it's because no one's told you that you can't do that.
Yeah, I think that's a key challenge, as we've seen over the years. The number of courses have been diminishing quite drastically, and I can say that even in the last even from my degree, from my degree, it's there's a lot less than there was available. That was, well, a lot less now than available then. Okay. Yes. Another question here is that AI is not yet great for creating visual maps. Do you think this is going to change?
I hope so. I mean, you're absolutely right there, Helen. It's terrible. At this point in time, most large language model or generative AI systems create, in effect, a pastiche of a map. They know what a map looks like vaguely, and that it's got a title and perhaps a north arrow and a legend, but they don't fundamentally understand the geographical information that you need to create the map. And therein lies the problem. We need to make our geographical information we publish richer, and the work that Richard has been doing is going along this way of saying, this data needs to be semantically richer. It needs to be held in graph databases where the geospatial relationships are embedded in the data. Then we'll get better maps, but it's a long way off at this point in time.
I think it's getting there though, and again, that final one I showed you, we only made that a week ago. So it is changing very rapidly, but that's where the roles of all of you still are valid, because you need people like you to prompt the AI tool to create the map. If you just go onto ChatGPT, you get the kind of maps that Ed's just described. But if you've actually got your own model and you've trained it, or you're using something like RAG and the right back end there, it is getting better.
Okay. No, thank you very much for both of you. The good answers there for the question. Right. Right. A few more questions left. Richard, is there any reason you chose to go with Esri instead of open source such as Leaflet?
So as someone who was in the team that developed what was called GeoTools, that eventually became GeoServer, and I've spent most of my career using those things and Leaflet. Yes, it was partly because NERC had a license for Esri Enterprise, partly that we would have had to do a heck of a lot of heavy lifting with 40. It's a lot of data, this, in a wide range of formats, and we'd have had to have a lot of staff and software engineers to make it all work in GeoServer. Users also in the public sector, despite what we might think, essentially are all using Esri products and are familiar with it, and things like DEFRA, Met Office, so you can join things up. So we could do it. We could have gone that way, but for various reasons, we had access to the right licenses. Users said they liked the idea of building story maps. I mean, I remember presenting at a FOSS4 GIS conference a few years ago and saying, where is the AGOL ArcGIS Online version of QGIS leaflet? Now, I know there is a plugin. You press a button in QGIS and you can get a leaflet map, but you still have to do a heck of a lot of work then to make it a usable map. So I put that challenge out there several years ago, and where's the simple press a button and you get, the sort of AGOL map from ArcGIS Pro? Where's the QGIS version? And I know that it's not beyond the ability of the community to do that, but we don't seem to have done it.
Okay. No, thank you very much for the answer there. Right. Looks like we have our final question here. It's how is data quality managed? Spatial data answers are only as good as the data they're built from. How does DHS ensure that data quality is appropriate for its intended purpose, and that the elements of cartography is considered when the data sets are made or ingested into data centers?
So NERC have their environmental data service in those 5 data centers. There is a lot of quality control and various kite marks associated with those data centers. So they are the gatekeepers of the data, not ourselves. So they've already done that great job of making sure the data meets certain standards before it's allowed to be published through the data center. So we do not curate data, that's the data centers. Where we're bringing in other organizations' data, it will be from the likes of DEFRA, the Met Office, Environment Agency, SEPA, Natural Resources Wales, who have also gone through there. So it's the actual, all we're doing really is aggregating and pulling all this disparate data together in DSH, but it's coming out of what you would say are official sources. We're not just grabbing random data. We do some work ourselves, and we do have cartographers who create map compositions as well. Equally, though, the user has some flexibility around that to do that themselves as well.
Okay, thank you very much then. All right, so we're coming to the end of the session. So I think I'll just ask both our speakers if they have any final comments or takeaways they want people to have, and I'll start with Ed.
No, other than to thank you for this opportunity, and to thank the audience for listening, and hopefully everyone's enjoyed their lunch with us nattering in their background. But do feel free to reach out. I'm kind of findable on the internet if you've got any follow-ups or comments. But no, thank you for the opportunity.
Richard?
Yeah, same for me. Thank you very much for listening. I hope that was useful. And yeah, you can find me. I've put a link to the tools on there, so do reach out if I'm more than happy to have a follow-up chats with people. I think importantly as well, people like yourselves are still valid and relevant and important. We still need people to be able to make maps, or as we both said earlier, we see a lot of crap maps out there, and we need to stop that.
Okay, no, thank you very much, Richard. So I just want to say thank you to Ed and thank you to Richard for the interesting talks and the conversation we've had now. So I want to thank finally our audience for joining us. Thank you for joining us. Thank you for the listening. Thank you for the questions, and we hope you'll join us for future talks that the BCS holds. So thank you very much, everyone, and goodbye for now.